Our universe conceals shadowy structures that defy the laws of physics. We are about to journey into the cosmic abyss to explore 25 dark galaxies whose very existence terrifies the scientists who study them. By the end of this exploration, you will understand the fundamental pillars of reality that these ghostly islands of darkness are forcing us to question. What if everything we know about matter and gravity is built upon an incomplete picture? How can a galaxy made of almost nothing even hold itself together? What does it truly feel like to peer into the void and have the void peer back? Are you prepared to confront what the darkness might reveal? One galaxy stands as a ghostly monument to our cosmic ignorance. Dragonfly 44 drifts through the Coma Cluster, a cosmic phantom so faint it was missed for decades. Its name comes from the Dragonfly telephoto array, the specialized instrument that finally revealed it, not as a blaze of stars but as a wispy, ethereal smudge. This is an ultra-diffuse galaxy, a realm where starlight is almost an afterthought. For its immense size, comparable to our own Milky Way, it should shine brightly with the light of hundreds of billions of stars. Instead, it possesses only about 1/100% of the stars we would expect. The sheer lack of stellar bodies makes it a celestial ghost town, a vast structure of almost nothing. Its very existence shatters conventional models of how galaxies are born and built. How can something so massive be made of so little? The answer is both terrifying and illuminating. Dragonfly 44 is not held together by the stars we can see, but by an immense, invisible scaffold of dark matter. Calculations suggest that this galaxy is 99.99% dark matter, a ratio so extreme it feels impossible. It is a perfect cosmic balance, a fragile equilibrium where the whisper of visible matter is completely dominated by the silent, gravitational roar of the unseen. This discovery forces a profound question. Is Dragonfly 44 a unique cosmic fossil, or is it merely the first of countless shadow galaxies we have yet to find? If Dragonfly 44 is a ghost town, then Segue 1 is a cosmic crypt. This tiny, ancient satellite of our own Milky Way is one of the darkest objects ever recorded in the heavens. It is so faint that it was discovered not by its light, but by the subtle gravitational tug it exerts on the stars around it. Imagine a whisper so quiet it can only be heard by the way it moves the air. Segue 1 is that whisper, a relic from the universe's infancy, containing only a few hundred ancient stars. For its diminutive size, it should be easily torn apart by the colossal gravity of our galaxy. Yet it endures, held together by a secret of immense density. The sheer amount of dark matter packed into this faint smudge is almost beyond comprehension. Astronomers calculate that Segue 1 is over 1,000 times more massive than its visible stars alone would suggest. This means it is comprised of 99.9% dark matter, a concentration so pure it defies all logic. This tiny galaxy is not just a curiosity, it is a time capsule, a pristine fossil from an era when the first structures in the universe were clumping together from the primordial dark matter. Its existence provides a terrifyingly clean laboratory to study the fundamental properties of the unseen stuff that shapes our cosmos. Why is its faintness so frightening? Because it proves that the most dominant structures in the universe could be all but invisible, hiding in plain sight, their true nature masked by a deceptive emptiness. Segue 1 forces us to ask a chilling question. How many other shadows are drifting just beyond the edge of our perception? The silence of Segue 1 finds an even deeper echo in the faint glow of Triangulum II. This tiny satellite galaxy, orbiting our own Milky Way, is so dim that its individual stars are almost impossible to distinguish from the background. Yet this cosmic speck holds a gravitational secret that has left researchers stunned. The few stars within Triangulum II are moving at velocities so high they defy all logic. They are racing around at speeds that should have long since flung them out into the emptiness of intergalactic space. The only possible anchor, the only force powerful enough to keep these stellar speedsters tethered, is an immense and concentrated gravitational pull. That pull points to one terrifying conclusion. Triangulum II possesses one of the highest concentrations of dark matter ever measured in any known galaxy. The ratio of dark matter to normal matter here is so extreme it redefines the word dominance. This is not a place where dark matter merely influences the structure. This is a realm where dark matter is the structure, with the visible stars acting as nothing more than fleeting fireflies in an overwhelming, invisible cage. Scientists fear this extreme density because it challenges the very models we use to understand how dark matter particles should behave. Could such a dense concentration imply that dark matter particles are colliding with one another, annihilating in a flash of gamma radiation that we have not yet detected? Or does it suggest something even more unsettling, that our fundamental understanding of gravity itself is flawed on these smallest of cosmic scales? Triangulum II is not just a dark galaxy. It is a gravitational paradox, a tiny, silent object whose very existence whispers that we are missing a crucial piece of the cosmic puzzle. But the darkness does not confine itself to clear-cut categories. Drifting in the void between the constellations Ursa Major and Leo Minor is an object that defies easy classification, a cosmic riddle named Willman I. At first glance, it appears as nothing more than a sparse collection of ancient stars, a mere handful of stellar embers, but look closer and the mystery deepens. Is this a true dwarf galaxy, held together by its own dark matter halo? Or is it just a star cluster, a group of stars born together and now slowly drifting apart? The debate over its identity is fierce, and it strikes at the very heart of how we define the building blocks of the cosmos. The problem lies in its faintness and its sparseness. It contains so few stars that astronomers struggle to measure its total mass accurately. If it is a galaxy, then it must be filled with dark matter to explain its gravitational cohesion. If it is merely a cluster, then its stars alone should account for its gravity. The data remains stubbornly ambiguous, refusing to provide a clear answer. This uncertainty makes Willman I profoundly important. It represents a gray area in our cosmic taxonomy, a ghost in the machine of classification. If it is a galaxy, it is one of the darkest and most elusive ever found. If it is a cluster, its existence in such isolation is itself a puzzle. This single, faint smudge of light forces us to confront a fundamental question. Where do we draw the line between a family of stars and a true island universe? The fear surrounding Willman I is not about a monstrous density of dark matter, but about the limits of our own knowledge. It is a reminder that the universe is filled with ambiguous objects that do not fit neatly into our boxes, challenging us to rethink the very definitions we rely on to map the cosmos. The faintness of Willman I finds a cosmic cousin in the sprawling, ethereal form of Andromeda XIX. Orbiting our nearest large galactic neighbor, this satellite is not dense or compact, but exists as the very opposite. It is a galaxy stretched to its absolute limit, a web of stars so thinly spread that its total brightness is less than that of a single bright star within our own galaxy. If the Milky Way were a bustling metropolis, Andromeda XIX would be a handful of distant farmhouses scattered across an entire state. Its stars are separated by vast gulfs of empty space, making it one of the most diffuse objects ever discovered. The existence of such a wispy structure presents a direct and unsettling challenge to our models of dark matter. We believe that galaxies are born within halos of this invisible substance, with the gravity of the halo pulling in gas and dust to form stars. These dark matter halos are predicted to have a certain density, a certain gravitational punch that dictates how tightly a galaxy can be packed. Andromeda XIX defies that prediction. Its incredible diffuseness suggests its dark matter halo is itself incredibly spread out and weak, a wispy ghost of a halo that failed to gather its material into a more coherent form. This forces a difficult question. Do our theories about the fundamental properties of dark matter need a radical rewrite? Perhaps dark matter particles behave in ways we have not anticipated, allowing for such faint, fluffy halos to exist. Or maybe the violent tidal forces of its parent galaxy, Andromeda, have stretched this galaxy beyond recognition, stripping away its stars and smearing its dark matter across the void. The fear surrounding Andromeda XIX is not about a terrifying density, but a terrifying lack of it. It shows us that dark matter's influence can be so faint, so diluted, that it creates galaxies which are barely there at all, phantoms that test the very limits of what we can call a galaxy. The fragility of Andromeda XIX is not an isolated case. Its neighbor, Andromeda XXI, presents an even more profound cosmic contradiction. This satellite galaxy is immense in physical size, sprawling across a vast tract of space, yet it emits a light so feeble it barely registers against the blackness of the cosmos. Imagine a nation the size of a continent, but with a population of only a few dozen people, their homes lost in an overwhelming landscape of emptiness. That is the essence of Andromeda XXI. Its stars are so few and so far apart that the galaxy's total brightness is less than that of a single moderately bright star in our own night sky. How can something so large be built with so little material? The answer lies in the ghostly hand of its dark matter halo, but this halo is unlike the dense, powerful anchors we find in galaxies like Triangulum II. The dark matter environment surrounding Andromeda XXI appears to be strangely impotent. It has the gravitational strength to carve out a massive territory in space, but it utterly failed to pull in enough gas and dust to create a significant number of stars. This creates a cosmic paradox, a giant that never grew up, a vast structural framework with almost nothing built upon it. This forces astronomers to confront a terrifying limit of galaxy formation. Our models suggest that dark matter halos of a certain size should inevitably lead to a certain level of star formation. Andromeda XXI defies that expectation, living in a state of perpetual failure. Was it starved of gas by its parent galaxy, or is its dark matter fundamentally different, incapable of fostering the birth of suns? This faint giant stands as a monument to a stalled universe, a haunting reminder that the rules of cosmic construction may be far more complex and varied than we ever dared to believe. This ghostly giant orbits our own Milky Way, yet you could stare directly through its heart and see the universe beyond. Crater II is the fourth largest satellite galaxy we know of, a realm so vast its stars are scattered across an area larger than the full moon in our sky. But its immense size is a cosmic illusion, a trick of emptiness. Despite its grand dimensions, Crater II is one of the faintest objects ever discovered, a ghost ship adrift on the galactic tides. How does such a colossal structure, built with so little starlight, not simply fly apart? The answer lies in a delicate, invisible dance. Crater II is held together by a dark matter halo of surprising subtlety. This is not the dense, crushing anchor of Triangulum II, but something far more diffuse, a vast and wispy gravitational net that gently cradles its few stars. Its existence forces a critical reevaluation of what a dark matter halo can be. We used to imagine these halos as having predictable densities and sharp edges, but Crater II's halo appears to be strangely fluffy and extended. It possesses enough gravity to define a massive territory, but that gravity is spread so thin that it failed to gather the raw materials for a brilliant stellar display. This suggests that dark matter halos are not all cut from the same cloth. They can exist in a spectrum of states, from the intensely concentrated to the incredibly tenuous. The fear surrounding Crater II is not its darkness but its quiet normalcy. It implies that these large, faint, dark matter-dominated galaxies might be incredibly common, a hidden population of cosmic giants we have simply overlooked because they emit almost no light. If true, our census of the local universe and our understanding of its fundamental architecture is profoundly incomplete. Lurking in the galactic shadows, Andromeda II is a ghost that should not exist. This recently discovered satellite of the Milky Way is a cosmic paradox of staggering proportions. It is as large as the Large Magellanic Cloud, one of our most prominent satellite galaxies, yet it emits less than 1/10,000th of the light. If the Large Magellanic Cloud is a brilliant chandelier, Andromeda II is a single, dying ember, somehow occupying the same vast space. Its discovery alone was a shock, but its properties have ignited a firestorm of controversy among astronomers. The central puzzle is its wild inconsistency. Andromeda II is not uniformly faint. Observations reveal bizarre pockets where it flickers with unexpected brightness, as if parts of this ghost are briefly, mysteriously catching fire. These fluctuations are not easily explained by the gentle aging of its ancient stars. Something far more dynamic seems to be at work within this dark giant. The leading and most thrilling hypothesis points to a violent and unseen interaction. Scientists suspect that within Andromeda II's vast, fluffy dark matter halo, particles of this invisible substance are violently colliding with one another. According to some theories, when certain types of dark matter particles annihilate upon impact, they could release a burst of energy. This energy would then heat up the sparse gas within the galaxy, potentially triggering brief, localized waves of star formation. In this scenario, the flickers of brightness we see are the death throes of dark matter itself, a faint cosmic fireworks display powered by the annihilation of the universe's most mysterious material. This makes Andromeda II a living laboratory, a place where we might be witnessing dark matter not just as a gravitational anchor, but as an active, destructive participant. If this is true, it would be the first direct evidence of dark matter interacting with itself in a non-gravitational way, a discovery that would shatter our current models and open a new window into the hidden cosmos. The fear surrounding Andromeda II is not just its size or its darkness, but its strange, flickering life. It suggests that dark matter may not be entirely silent and passive. It might, in its own invisible way, be screaming. The flickering ghost of Andromeda II suggests dark matter can be active, but what if a galaxy had no dark matter at all? This is not a theoretical question, but the reality of a cosmic rebel known as NGC 1052 DF2. It drifts through space as a living, breathing paradox, a galaxy that seems to defy the very law of cosmic gravity. While every other galaxy we have explored is dominated by the invisible pull of dark matter, this one appears to be built from almost nothing but the stars we can see. Its existence sends a chilling tremor through the field of cosmology. How can a stable galaxy form without the gravitational scaffolding of dark matter to hold it together? The initial measurements of NGC 1052 DF2 were so bizarre that scientists double-checked and then triple-checked their data. They studied the motions of its star clusters, expecting to find the high velocities that would betray the presence of a massive, unseen anchor. Instead, they found the clusters moving with a slow, gentle pace that perfectly matched the gravitational pull of the visible stars alone. There was no extra mass, no hidden hand, no dark matter. This discovery turned cosmology on its head. For decades, our entire understanding of the universe has been built upon the idea that dark matter is the fundamental framework, the cosmic skeleton upon which galaxies are built. NGC 1052 DF2 suggests that skeleton might be optional, and that idea is terrifying. It forces cosmologists to confront a nightmare scenario. What if our foundational theory is wrong? The debates over this galaxy have been intense and deeply personal. One camp argues the measurements are a fluke, that we are misinterpreting the data, or that the galaxy is simply a unique product of a violent galactic encounter that stripped its dark matter away. The other camp accepts the data at face value, seeing this galaxy as proof that our models are incomplete, that galaxy formation is a far more diverse and mysterious process than we ever imagined. This single, faint smudge of light has become a battleground for the soul of cosmology. Its very existence does not just add a new piece to the puzzle, it threatens to break the puzzle board in half, forcing us to ask if we have been building our cosmic house on a foundation of sand. The mystery of NGC 1052DF2 deepened with the discovery of its apparent sibling, NGC 1052DF4. If the first galaxy was a shocking anomaly, this second one was a confirmation of a terrifying pattern. Here was another stable, rotating galaxy where the visible stars and gas accounted for virtually all of its mass. The careful measurements of its globular clusters revealed the same unsettling truth, a gentle, slow dance of stars that required no dark matter to explain their motions. The chance of two such impossible objects existing in the same region of space felt like more than a coincidence. It felt like a message. The scientific community was thrown into a state of profound uncertainty. How could these cosmic structures, which looked and behaved like classic dwarf galaxies, exist without the fundamental ingredient we believed was essential for their very formation? The implications were staggering, pointing toward a universe with two distinct paths for building galaxies. One path, the one we thought was universal, uses dark matter as a gravitational seed to gather gas and form stars. The other path, revealed by these two rebels, somehow builds galaxies from normal matter alone. But how could such a process even begin without the immense pulling power of a dark matter halo to overcome the universe's expansion? The existence of these galaxies suggests that our cosmic building codes are far more flexible and far stranger than we ever imagined. The fear they inspire is not about a monstrous presence, but about a fundamental absence. They are cosmic counterexamples, living proof that the rules we have written for the universe might only apply to some of its inhabitants, leaving the rest to operate on a physics we do not yet comprehend. This ghostly presence, UGC 1378, drifts through the void as a testament to cosmic subtlety. It belongs to a class known as low-surface brightness galaxies, realms where starlight is so thinly spread it barely registers against the blackness of space. If our Milky Way were a brilliant city at night, UGC 1378 would be a vast rural landscape with a single, dim light bulb shining on each square mile of territory. Its faint, ethereal glow makes it one of the most difficult objects in the universe to observe directly. Peering at it through a telescope is like trying to read a book by the light of a candle a mile away. The faint starlight we can detect is merely the tip of a colossal, invisible iceberg. The true nature of UGC 1378 is revealed not by its light but by its gravity. The rotation of its sparse gas and stars is far too swift to be explained by the pull of the visible matter alone. This galaxy is spinning so fast that it should have torn itself apart eons ago. The only thing holding it together is a massive, dominant halo of dark matter, an unseen gravitational engine that comprises the overwhelming majority of its mass. This profound dominance of the invisible is what makes such faint galaxies so terrifyingly important. Their elusive nature suggests they are not rare cosmic flukes, but could represent the most common type of galaxy in the entire universe. We have built our census of the cosmos by cataloging the bright, the obvious, and the luminous. But what if the true cosmic landscape is dominated by these shadowy giants, these faint islands of darkness that slip through the nets of our surveys? The fear surrounding UGC 1378 is not about its individual properties, but about the sheer multitude it might represent. We are forced to wonder if we have been mapping only the well-lit islands in a sea of infinite dark continents. Malin I is a cosmic phantom of almost unimaginable scale. This galaxy is one of the largest spiral systems ever discovered, a titan whose disk spans hundreds of thousands of light-years, dwarfing our own Milky Way. Yet for all its immense physical size, it is one of the faintest objects in the sky, a low-surface brightness galaxy on a colossal scale. Imagine a city as vast as an entire continent, but where every streetlight is so dim you can only see it from the edge of town. That is the paradoxical nature of Malin I. Its stars are spread so thinly across its enormous expanse that its total glow is pathetically weak, a whisper of light from a structure of staggering proportions. How can something so large remain so ghostly? The answer lies in a failure of cosmic condensation. Malin I possesses a massive dark matter halo, a gravitational framework capable of holding a truly giant galaxy together. But for reasons we do not fully understand, this halo never managed to pull in enough gas to form stars efficiently. The result is a universe of mostly empty space, a vast, spinning disk where stars are lonely beacons separated by immense dark voids. This giant's faintness is what makes it so terrifyingly significant. For decades, our telescopes were simply not sensitive enough to detect such ethereal objects. Malin I was a hidden giant, lurking in plain sight until specialized imaging techniques finally revealed its ghostly outline. Its existence forces a chilling question. If a galaxy this enormous could evade our detection for so long, how many other invisible giants are floating in the darkness? The fear is that Malin I is not a rare exception, but a prototype for a vast, hidden population of dark galaxies. Our current map of the universe, built on the light of bright stars, may be missing the true cosmic giants, the silent, shadowy leviathans that form the unseen backbone of the cosmos. The search for darkness takes an even more radical turn with a ghost named Galaxies XXI. This is not a faint galaxy with a few stars, but a candidate for something far more extreme. A structure seemingly made of nothing but hydrogen gas and an overwhelming amount of dark matter. It was discovered not by its starlight, but by the faint radio whisper of its cold hydrogen gas, a signature that revealed a massive object rotating in the void. The sheer amount of gas implied a gravitational anchor of immense proportions, a halo of dark matter with the mass of a small galaxy. Yet when astronomers pointed their most powerful optical telescopes at its location, they saw nothing at all. No stars, no stellar nurseries, not even a single faint smudge of ancient suns. It appeared to be a pure dark matter galaxy, a cosmic skeleton without any flesh, a gravitational structure that never managed to clothe itself in light. The implications of such an object are staggering. It suggests that dark matter can form its own islands in space, completely independent of the normal matter that makes up our visible world. This challenges the very core of galaxy formation theory, which posits that dark matter halos are the essential seeds that gather gas, which then condenses into stars. Galaxies XXI presents a universe where that process can fail utterly, leaving behind a naked halo, a ghost of pure gravity drifting silently through the cosmos. But its existence is fiercely debated. Some scientists argue that what we are seeing is not a single dark galaxy, but the stretched and distorted debris from a violent galactic collision, a tidal tale of gas misidentified as a coherent structure. This controversy cuts to the heart of the scientific process. The fear surrounding Galaxies XXI is not just about its darkness, but about our ability to interpret the faint signals from the void. If it is real, it opens a door to a hidden population of pure dark matter halos, fundamentally altering our senses of the universe. If it is an illusion, it serves as a humbling reminder of how easily the cosmos can deceive us. The question it forces upon us is terrifying in its simplicity. Are we looking at a new class of object, or are we seeing only what we want to see in the endless dark? Another ghost haunts the Virgo cluster, a faint whisper of hydrogen gas known as Hi 1225+01. This object was not found by its starlight, but by the signature of its cold, neutral hydrogen, a radio frequency tune picked up by the world's most sensitive radio telescopes. What they heard was the unmistakable rhythm of a rotating galaxy, a vast disk of primordial gas spinning gracefully in the void. But when they looked for the source of the gravity holding this immense gas cloud together, they found almost nothing. No bright spiral arms, no central bulge of stars, just a dark, swirling sea of the universe's most basic building block. This is a galaxy dominated not by darkness in the sense of unseen matter, but by the very raw material of stars themselves. It is a cosmic blueprint, a half-finished project frozen in time. The existence of such a gas-rich, star-poor galaxy presents a direct challenge to our understanding of cosmic evolution. We have long assumed that when a dark matter halo gathers enough gas, the process of star formation begins almost inevitably, a natural chain reaction that lights up the darkness. HI 1225+01 defies that assumption. It has the fuel and it has the gravitational framework, yet it has failed to ignite. This forces scientists to reconsider the entire timeline of galaxy formation. Perhaps the transition from a cloud of gas to a brilliant island of stars is not a swift and certain process, but a fragile and easily interrupted one. What could stall a galaxy's birth? The answer might lie in its environment. The Virgo cluster is a violent, crowded metropolis of galaxies, filled with searing intergalactic gas and intense gravitational tides. It is possible that this dark galaxy is being stripped and pressurized, its gas kept too agitated and diffused to collapse into the dense cores that become stars. Or perhaps it is simply too young, a late-forming structure that we are catching in its earliest, most primordial state, a cosmic egg that has not yet hatched. This ghost of pure potential force is a humbling realization. Our theories were built on the successful galaxies, the ones that figured out how to shine. But for every brilliant spiral, there might be countless others that stalled, failed, or were stillborn, their light forever lost to the darkness. HI 1225+01 is a reminder that the universe is not just a gallery of finished masterpieces, but a workshop filled with abandoned sketches and incomplete dreams. Coma P drifts through one of the most crowded and violent neighborhoods in the known universe, the Coma Cluster. Here, thousands of galaxies are packed together in a seething gravitational maelstrom, a cosmic battlefield where smaller galaxies are routinely torn apart by immense tidal forces. Against this backdrop of chaos, the continued existence of Coma P is nothing short of a miracle. This ultra-diffuse dwarf galaxy is a wisp of a thing, a faint collection of ancient stars that should have been shredded and dispersed by its aggressive neighbors eons ago. Yet it persists, a ghostly survivor holding its fragile form. Its secret is an astonishing density of dark matter. The gravitational grip of its invisible halo is so powerful, so unyielding, that it can withstand the relentless pulling of the entire cluster. This makes Coma P a perfect natural laboratory. By studying how its dark matter halo behaves under such extreme external pressure, scientists can probe the fundamental nature of the particles themselves. Is the dark matter within Coma P cold and collisionless, as many models suggest, simply flowing through itself without friction as the cluster's gravity tugs on it? Or does it show signs of interacting, of being slowly stripped away, revealing a more complex particle physics? The answers locked within this faint smudge of light could tell us if dark matter is a simple, silent anchor, or a dynamic substance that can be shaped and eroded by the universe's most powerful forces. NGC 2915 presents a cosmic contradiction of vibrant light and overwhelming shadow. This blue compact dwarf galaxy blazes with the furious energy of star formation, its core a brilliant nursery of young, hot blue stars. Yet this intense fire is just a tiny spark at the heart of an immense and invisible beast. The true scale of NGC 2915 is revealed not by its light, but by the silent rotation of its hydrogen gas, which extends outward in a vast, faint disk that dwarfs the bright central region. This gas is moving at speeds that are simply impossible unless it is gripped by the gravity of a dark matter halo of staggering size and mass. The result is a profound mismatch, a galaxy where the visible, star-forming core is just a small, bright trinket perched on the edge of a colossal, invisible wheel. Why does this disconnect between light and mass terrify scientists? Because it suggests that dark matter does not always neatly follow the distribution of the stars we see. In most galaxies, the dark matter is concentrated in the center and thins out toward the edges. But in NGC 2915, the dark matter halo is so extended and dominant that it completely overpowers the visible structure, dictating the motion of gas far beyond where any stars exist. This could mean that the properties of dark matter itself are more complex than we thought. Perhaps the particles have a unique way of interacting with each other or with gravity that allows them to form these vast, fluffy halos that refuse to condense in sync with normal matter. Another, more unsettling possibility is that we are witnessing the aftermath of a violent event, a collision or merger that stirred up the dark matter, scattering it into this immense configuration while leaving the central stellar core intact. This single, brilliant blue dot forces us to confront the limits of our models. It shows us that dark matter can sculpt the cosmos on a scale that completely decouples from the light we use to map it, creating a hidden architecture of gravity that we are only beginning to perceive. DDO 154 is a cosmic underachiever, a small, unassuming dwarf galaxy that has become one of the most important objects in the universe for understanding the dark matter puzzle. It is not a brilliant spiral or a dense elliptical, but a gas-rich backwater, a swirling pool of primordial hydrogen where star formation is a rare and quiet event. Its significance lies not in its appearance, but in the perfect clarity of its motion. Astronomers have mapped its rotation curve with exquisite precision, charting the speed of its hydrogen gas from the core all the way out to its faintest edges. What they found has become a textbook example of dark matter's influence. The gas in the outer regions of DDO 154 is orbiting at the same high speed as the gas near the center. This is impossible under the laws of gravity as defined by visible matter alone. If the stars and gas we see were all that existed, those outer clouds should be slowing down, drifting lazily like leaves in a pond. Instead, they race around as if whipping around an unseen center of immense gravity. This flat rotation curve is the classic, unmistakable signature of a dominant dark matter halo. DDO 154's rotation became a benchmark, a clean and undeniable data set that confirmed the presence of the invisible on a galactic scale. Yet, this very clarity also complicates our models. The distribution of its dark matter does not perfectly match the simplest theoretical predictions. Its halo appears to be less concentrated in the core than some models suggest it should be. This small deviation is a massive headache for cosmologists. It forces a question: is our understanding of how dark matter clumps together, even in a seemingly simple galaxy, fundamentally flawed? DDO 154 stands as both a confirmation and a critique, a dark galaxy that proved the rule, then immediately began to question it. IC 2574 drifts in the emptiness, a sprawling dwarf galaxy that feels less like a finished structure and more like a cosmic construction site frozen in time. Its most striking feature is not its stars, but its immense, swirling clouds of pristine hydrogen gas. These vast, cold reservoirs are the raw, unused fuel for star formation, stretching across the galaxy in great, dark lanes. Yet for all this available material, IC 2574 is forming new stars at a lethargic, almost reluctant pace. It is a galaxy caught in a state of arrested development, a living fossil from the early universe. This primitive state offers a priceless window into how the very first galaxies must have looked and behaved. They were not these brilliant, orderly spirals, but rather loose, gas-rich aggregations, slowly and inefficiently figuring out how to turn their raw material into suns. The reason for its sluggish evolution lies in its silent partner, dark matter. The rotation of those immense gas clouds reveals the presence of a massive, dominant dark matter halo, providing the gravitational stability that allows this primordial scene to persist for billions of years. Without that invisible anchor, the gas would have either collapsed into a burst of stars long ago or simply drifted away into the void. This is what both enlightens and unsettles researchers. IC2574 is a perfect natural laboratory, a preserved relic that allows us to test our theories of infant galaxy growth against a real-world example. But its existence also raises a profound and troubling question. Why did some of these early structures, like our own Milky Way, go on to become brilliant cities of stars, while others like IC2574 remained cosmic backwaters, hoarding their potential but never quite fulfilling it? The fear is that we are witnessing a universe where the path of cosmic evolution is not preordained, but is instead a delicate balance of internal properties and chance environmental factors, leaving some galaxies forever waiting for a spark that may never come. UGCA 442 quietly defies expectations, a low-mass galaxy where the rules of gravity seem to rewrite themselves. Its rotation curve presents a puzzle that has left astronomers deeply unsettled. According to our best models, a galaxy of its small size and faint luminosity should possess a dark matter halo of a certain predictable strength. Its visible stars and gas should dictate a gentle, slowing spin in its outer regions. But the data tells a different, more chaotic story. The hydrogen gas orbiting this dwarf galaxy does not move in a smooth, predictable pattern. Instead, its rotation is messy and inconsistent, with some regions spinning far too fast for the visible mass, while others lag behind in a way that defies a simple dark matter explanation. This is not the clean, dominant signature of dark matter we saw in DDO 154. This is a gravitational fingerprint that is smudged and unclear. How can a single, small galaxy have such a conflicted relationship with gravity? The anomalies in UGCA 442 are so pronounced that they force scientists to consider radical alternatives. One terrifying possibility is that our concept of dark matter itself is incomplete. Perhaps dark matter is not a single type of particle, but a family of different particles with varied properties. This galaxy's strange rotation could be the result of a complex interplay between different kinds of dark matter, some that clump tightly and others that remain diffuse, creating a lumpy, unpredictable gravitational field. An even more profound alternative challenges the very laws of physics. Theories like modified Newtonian dynamics, or MUND, propose that our understanding of gravity is simply wrong on the scale of galaxies. This idea suggests that gravity behaves differently when its pull becomes incredibly faint, producing the effects we mistakenly attribute to dark matter. In the case of UGCA 442, its low mass and weak acceleration could place it directly in the regime where these modified laws take over, creating the strange rotational velocities we observe without any need for invisible matter. The fear this galaxy inspires is not about a monstrous presence, but about a potential crack in the foundation of modern physics. It stands as a quiet rebel, its messy spin whispering that the cosmos might be governed by rules we have not yet dreamed of, forcing us to question whether the darkness is a thing or merely a shadow cast by our own ignorance. Camelopardalis B drifts in the profound shadow of the Andromeda Galaxy, a ghost so faint it evaded our gaze until incredibly recently. This ultra-faint dwarf satellite is not merely dim, it is one of the darkest confirmed objects in the entire cosmos, a place where starlight is almost a myth. Its recent discovery was not a matter of luck, but a triumph of advanced technology and painstaking data analysis, peeling back the blackness to reveal a silhouette of a galaxy. The profound darkness of Camelopardalis b is its most terrifying feature. It contains so few stars that its total luminosity is less than a single red giant star within our own galaxy. We are not looking at a city with its lights off, but at a continent-sized structure where only a handful of light bulbs flicker in the overwhelming emptiness. This extreme faintness forces a critical question. How did we miss something so large, so close, for so long? The answer is that our astronomical surveys have always been biased toward the bright and the obvious. We map the universe by its shining beacons, completely unaware of the shadowy archipelago that surrounds us. Camelopardalis b is a stark reminder of our own cosmic blindness. Its existence and the sheer difficulty in finding it suggests a terrifying probability. If such an extremely dark object can hide in our own galactic backyard, then there must be countless more just like it, an unseen population of dark galaxies stretching far beyond the limits of our current vision. Every time we build a more sensitive telescope or develop a new analytical technique, we peel back another layer of darkness to find more of these phantoms. This leads to a humbling realization. The sparkling universe of brilliant spirals and radiant ellipticals that we see in telescope images may be the exception, not the rule. The true cosmic landscape could be a sea of darkness, punctuated by rare, brilliant islands of light. Pisces 7 drifts at the very edge of detection, a phantom so faint its discovery was like hearing a single raindrop in a thunderstorm. This ultra-faint dwarf satellite of our Milky Way was only confirmed in the last few years, a testament to the relentless pace of discovery in the darkest corners of our cosmic backyard. It is not the properties of Pisces 7 itself that are terrifying, but what it represents. It is one more day to point in a growing and unsettling census, another shadowy face emerging from the crowd. For decades, we believed our local group of galaxies was a well-mapped family, a collection of brilliant spirals and their brighter satellites, but Pisces 7 and its kin tell a different story. They are the ghosts found only by sifting through the deepest digital surveys, their faint starlight teased out by algorithms that scan the heavens pixel by pixel. Each new discovery like this one pushes the boundary of what we consider a galaxy, challenging our definitions with objects that are little more than a gravitational whisper and a handful of ancient stars. This expanding population of dark galaxies forces a chilling statistical reality. For every bright satellite like the Large Magellanic Cloud, there could be dozens, even hundreds of these ultra-faint phantoms. Our local universe, it seems, is not a sparsely populated realm of brilliant islands, but a teeming metropolis of darkness where the luminous galaxies are the rare exceptions, the glittering skyscrapers in a city of invisible, sprawling suburbs. The fear is not about any single dark galaxy, but about the sheer scale of our ignorance. Every time our observational techniques improve, we find more of these shadows. How many more are still hiding just beyond the limit of our current vision? The darkness is not empty, it is crowded. The faint shadow of Pisces 7 is joined by another ghost, a celestial wraith named Pegasus V. This ultra-faint dwarf galaxy orbits our own Milky Way, a satellite so dim it was completely invisible until the European Space Agency's Gaia Observatory turned its precise gaze upon that region of the sky. Gaia's mission is not to find faint galaxies, but to map the positions and motions of billions of individual stars with unprecedented accuracy. It was in this vast, intricate star map that astronomers spotted the anomaly, a subtle clustering of a few dozen ancient stars moving in concert, a synchronized dance that betrayed the presence of a hidden gravitational anchor. Pegasus V itself is a mere wisp, but its discovery method is what truly terrifies and excites scientists. We are no longer just building bigger telescopes to peer deeper into the darkness. We are building smarter eyes, observatories that can detect the invisible through its subtle influence on the visible. Gaia found Pegasus V not by seeing a galaxy, but by inferring its existence from the synchronized drift of its constituent stars, a ghost revealed by the footprints it left on the starry background. This represents a fundamental shift in our hunt for the cosmos's dark architecture. It proves that the most elusive structures are not necessarily at the edge of the universe, but could be hiding in the very data we have already collected, waiting for the right algorithm to tease their secrets from the light. The discovery of Pegasus V and its kin forces a dramatic rethinking of galactic hierarchy. Our Milky Way was once thought to have a small, well-defined family of satellite galaxies. Now we know it is surrounded by a vast, invisible swarm of dark companions, a hidden entourage of ghosts. This changes everything we thought we knew about how large galaxies grow and evolve. They are not solitary giants, but the central hubs of immense, dark ecosystems, continuously absorbing and interacting with these faint satellites. Each new ghost, like Pegasus V, adds weight to a chilling new cosmic narrative, one where the bright, familiar galaxies we see are merely the tip of a vast, dark iceberg. The boundary between a star cluster and a dark galaxy is a frontier of terrifying ambiguity, and Cetus II stands directly on that line. This controversial object is a classic ultra-faint dwarf candidate, a faint smudge of light on the very edge of our observational capabilities. Its existence is debated precisely because it is so difficult to measure. Astronomers are forced to ask a deceptively simple question. Are we looking at a true galaxy, held together by its own powerful dark matter halo, or is it merely a globular cluster, a group of stars born together and now slowly drifting apart, bound only by their own collective gravity? The answer is maddeningly elusive. The key lies in measuring its mass, but with so few stars, the data is sparse and open to interpretation. The velocity of its stars, the telltale sign of a hidden gravitational anchor, is almost impossible to measure with any certainty. This uncertainty is what makes the boundary so frightening. It is a cosmic blind spot, a place where our tools and our theories reach their absolute limit. We are forced to classify the cosmos based on the faintest of whispers, and the consequences of a misclassification are profound. If we mistake a dark galaxy for a simple star cluster, we are erasing an entire island universe from our map, a structure that could hold vital clues about the nature of dark matter. Conversely, if we label a star cluster as a galaxy, we are polluting our data with false positives, building our understanding of the universe's dark architecture on a foundation of error. Cetus II is a ghost that refuses to be pinned down, a constant reminder that in the deepest shadows, the universe guards its most fundamental secrets with a frustrating silence. Indus I drifts through the celestial river of its namesake constellation, a sparse scattering of stars so faint it barely registers as a coherent structure. This celestial object embodies the very essence of ambiguity, a ghost that might be a dark galaxy or merely the shredded remains of a star cluster torn apart by our Milky Way's immense gravity. Its identity hangs in a delicate balance, and the force that tips the scales is the relentless pull of tidal forces. Imagine the Milky Way's gravity as a cosmic ocean tide, and Indus I as a fragile sandcastle built too close to the water's edge. With every orbital pass, the galaxy's gravitational pull tugs at this faint object, stretching its stars into long, thin streams and slowly siphoning them away into the galactic halo. If Indus I is a true dark galaxy, its own dense, invisible dark matter halo is fighting a desperate war of attrition against these tides, providing a gravitational anchor that allows it to retain its shape despite the assault. But if it is merely a cluster, a family of stars bound only to each other, then it has no such defense, and we are witnessing its slow and inevitable dissolution. This distinction is not just academic curiosity, it is fundamental to mapping the true architecture of the cosmos. Telling the difference between a dying cluster and a dark galaxy requires instruments of phenomenal sensitivity. Astronomers must measure the precise velocities of its individual, incredibly dim stars, searching for the subtle, telltale signs of that hidden dark matter anchor. A cluster's stars will all move at roughly the same speed, like a school of fish drifting in a current. But a dark galaxy's stars will be whipping around, their high speeds betraying the presence of the unseen mass holding them in a desperate gravitational embrace. Each new ghost like Indus 1 pushes our technology to the brink, forcing us to develop sharper eyes to see the shadows and more refined ears to hear the whispers of the dark. Our journey ends in the distant reaches of Eridanus with a ghost named Eridanus IV. This faint, far-flung system is more than just another dark galaxy. It is a key piece of evidence in one of cosmology's most enduring puzzles, the missing satellite problem. For decades, our most sophisticated computer simulations of the universe predicted a specific cosmic architecture. They showed that our Milky Way should be surrounded by many thousands of small, dark matter clumps, the leftover building blocks from its formation. Yet when we looked up, we could only find a few dozen bright satellite galaxies. The vast majority were missing, creating a glaring gap between theory and observation. Eridanus IV and its countless dark cousins are the solution to this mystery. They were not missing at all. They were simply hiding in the shadows, too faint for our telescopes to easily see. Each new discovery of an ultra-diffuse or ultra-faint galaxy like this one fills in a piece of that predicted population, slowly closing the gap between the simulated universe and the real one we observe. This growing catalogue of dark galaxies solves the numerical puzzle, but in doing so, it creates far deeper and more frightening questions. If these dark satellites are so common, why do they contain so few stars? What cosmic process stifled their growth, leaving them as failed galaxies, forever trapped in their primordial state? The answers seem to point directly to the enigmatic nature of dark matter itself. Perhaps dark matter is not the simple, cold, and collisionless substance we have long assumed. Maybe it possesses a subtle complexity, a slight ability to interact with itself or with normal matter that we have not yet detected. This tiny interaction could have generated just enough heat in the early universe to prevent gas from cooling and collapsing within the smallest dark matter halos, effectively starving them of the fuel needed to shine. Eridanus IV, then, is not an endpoint. It is a signpost pointing toward a more complex and mysterious dark sector. The very success of finding these dark galaxies to solve one problem has now opened a terrifying new frontier. We must now ask what dark matter truly is, not as a simple gravitational placeholder, but as a physical substance with properties we are only beginning to glimpse. The darkness is no longer just an absence of light. It is a vibrant, dynamic, and deeply hidden part of our universe, waiting for its secrets to be uncovered. These 25 dark galaxies are not cosmic anomalies. They are the rule. The brilliant, star-filled spirals and ellipticals that fill our telescope images are the rare exceptions, the glittering cities in a universe dominated by silent, dark continents. Every faint wisp, every gravitational whisper forces us to confront a terrifying truth. The universe we see is a fragile veneer, a luminous skin stretched over a hidden skeleton of dark matter that we cannot see, touch, or yet fully comprehend. These ghostly islands have shattered our most fundamental assumptions. They challenge the very laws of physics, presenting us with galaxies that have too much dark matter, too little, or in the most baffling cases, none at all. They defy our models of gravity and force us to question if we have been interpreting the cosmos through a flawed lens from the very beginning. The profound fear these galaxies instill in scientists is not about the darkness itself, but about the sheer scale of our ignorance. Each discovery solves one puzzle only to reveal a dozen more, deeper and more complex than the last. If our own galactic backyard is teeming with phantoms we never knew existed, what other dark secrets is the cosmos hiding in the vast, unexplored reaches between the stars? The journey into the abyss has just begun. The greatest mysteries of the universe are no longer distant quasars or alien worlds. They are the silent, invisible structures that form the true foundation of everything, waiting in the darkness for us to finally learn how to see.